So last week we started with Numpy. We started with Numpy, and we I proved to us why we need to make use of libraries like Numpy in carrying out some basic operation. And one important factor I mentioned last week was the issue of time. And since we'll be relating with data, we can have uh, data getting up to 1 million rows. And in that shape, um, if we want to maybe do something to such kind of heavy data, using iteration, using looping system, it's going to be too heavy. It may wear out our processing system. So um, engineers came up with quite a number of libraries that makes um, computation quite easier than the traditional way. So NumPy is one of those solutions that have been made available, and NumPy has its strength in mathematical computation. It has its strength in mathematical computation. So we proved that last week. I measure the time it takes when we are trying to iterate over a list, and I measure the time when we tried using this compression, and I measure the time when we used NumPy. So briefly, we'll just quickly go through some of the things we did last week, and we'll launch into what we have today. So last week I said NumPy is a library, and not all library. We need to reemphasize that not all libraries are installed normally on your laptop, no, on your Python workspace. Not all libraries are have been pre-installed. So there are some libraries we may be working with that we may have to install. So there's a way we can install all those packages, but something like library is already been installed to our Python namespace. So what we just have to do is import it. So we are importing NumPy. The name of the library is NumPy. And I explained that when you import a library, when you import anything, you can give it an alias, just like a nickname, so that when you're trying to refer to any function inside the library, you don't have to use the exact name, because some names can be boring, some names can be too long. So in this case, we imported NumPy as NP. So when we want to relate with NumPy, we use NP. And a very simple one example I gave last week was we used NumPy to just create a synthetic array, like just something from the blues. We just created it, and this in the concept of a range now. That means we're going from 0 to 19. So we're going from 0 to 19. So it's going to be an array. So NumPy deals with array. NumPy deals with array, and that's why they said most NumPy array is being used when working on something. So in this case now, let me run this cell. So by running that cell, I've imported a NumPy, and I've created a variable called favnum, and I can try and check what is inside favnum. So let me print that out right around this. So it's going from 0 to 19. So I can maybe, then I can explain last week. You can decide to step it. Maybe um let's step it by 2. Let me see how it goes. Okay, no. Can I step? Okay, let me um okay, so you can actually also step. So the first one marks where you're starting from, and the next one marks where you want to end, and the last one marks the step. So let's quickly revise over some of the things we did last week. So let me just return this back to 20. So one first thing we did was that, okay, take for example, in this case now, we can get the shape of favnum. So as it is, favnum is a one-dimensional array, It's a one-dimensional array, and as it has 20 rows with one column. 20 rows with one column. So if I want to know the shape, all I just have to do is just the name of the array, in this case 5num. That will be 5num. Then all I just do is do shape. Do shape dot shape. So that will give me the shape on the output. Sorry, and that shouldn't be there. So we have 20 by, so 20. So it's a one-dimensional array. It's not a two-dimensional array. If it to be two-dimensional array, you will see it as another value at the other side. So now also maybe you're not certain of the data type. No, we've talked about data type and all that. So you are not certain of the data type of the values inside your numpy array. You can know the data type by doing the name of the numpy array dot d type. So when I run this now, so it tells me that the items inside the array, they are integer, int 32. And as well, like I said, this is a one-dimensional array. I can decide to shape it, and like I want it to be a maybe two-dimensional array, so that maybe like 3 by 2 matrix or something. But here now we have 20 elements. So the kind of array we can form from here, we can form a 4 by 5 array. We can form a 5 by 4 array. What else can we do? You can form a 2 by 10 array. So just to match up. So as it is now, 5num is ranging from 0 to 19, so giving us 20 elements. So I can decide to reshape it. So I use the word, the name of the numpy array dot reshape. Then I'll give you the shape I want to give it. So if I give it 2, 10, so I'm talking about 2 rows with 10 columns. So when I run this now, as you can see, I have 2 rows and I have 10 columns. So it reshaped it like that. So as I'm doing this now, I can decide to give it a new name and say maybe my new favs. So you can create a fresh array from an existing array. My new fav. I run this now, so you can see. So 5num is still there. So if I run 5num now, you can see 5num still exists, still maintain what it is. So 5num still maintain what it is, but my new fav has been reshaped. So I can decide to even reshape it the more, maybe 5 by 4. So if I make it 5 by 4 and I print it out, I run this. So as you can see, I have 5 rows. So this is row 1, row 2, row 3, row 4, row 5. So we have 5 rows
All
by
size 4
4 columns. So another thing we can
4
also do
rows,
is,
5.
okay, do you have a question?
I said it is 4 columns, 5 rows.
Yes. So 5 rows, 4 column. So the rows, then the column. So we can also go ahead. Take for example, this is our new variable we just created from the existing variable. We can decide to give it a new data type. So by doing that, what you do is the name of your array dot as type. Then you pass in the new data type you want to give it. So I can give it, let's say, float. If I run this now, so as you can see, all the items, all the elements inside the inside the array, they've been changed. The data type has been changed to become a float. So you can do that. So also now, as it is, we may not, the application may look so vague for now, but when we begin to manipulate around various data sets, we begin to understand the strength of this. So take for example, like we discussed last week also, that there are some U functions like mass, mean, sum, standard deviation, STD, variance, and all that, that you may just want to run through the data in your array. And if you are to use a for loop to do that, the number of lines of code you'll be writing. So, but with just a single, you can just do it. So in this case now, maybe I want to find the maximum of the element in the new array I created, all I just have to do is my fav underscore okay, my new underscore fav. So if I do dot max, so that will give me the maximum value in that array, which is 19. If I do dot min, that will give me the minimum, which is 0. Then if I want to find the mean here, I can do that by saying min, and I run this. So as you can see, the mean here is 9.5, straightforward. So if I'm to use the normal traditional or natural Python language, that would have given me some stress. So I can decide to, maybe I'm interested in the median. I can do median. That's a median. Median. I run this. Oh, okay, sorry. 1, 2. Oh, okay. Okay, doesn't recognize median. Okay. Let me do sum. Let me add everything together. I think I can do sum. So let me run sum. So I have the sum to be 190. I can do variance. I can do STD. So the variance is 33.25. So it's just, so we call all these kind of, we call them U functions. They are just all those functions you can subject the items in your array to, and they are executed. Now, I also touched something last week, that what if, okay, you just want to add elements based on their rows. Maybe you want to add them, those on the rows, and not just everything. Now maybe I want to add 0 with 1 with 2 with 3, then that's all, then 4 5 6 7, that's all. So in that case, I can state the axis to which I want that to be performed. So I can, inside of here, I can say axis equals 1. So if I run this now, so it will add it up. So in each row now, so I have 6, I have this 10, is 17, is 22. So it has each element in each row, and it gave me out the answer. So if it's in on the column base, all I just have to do is put 0 here. So, and when I run this, you can see it adds it based on the column. So there are many methods that can really can play with. There are so many of them in NumPy, but these are just the basic ones, and I tell you, they will be very, very useful as we progress in our data science. So now today we'll be touching indexing and slicing. Indexing and slicing. Like in our case now, let me have this underneath here. Let me add the cell here. Insert a cell below. Okay, so now indexing, what it means is, we're familiar with list. Maybe I have list to be my norm. Let me say my norm equals, then I have it to be this way, this way, this way, this way. Then let's assume I want to get the third element, which is 4 5 6. I can just do my norm, then the position there. So 34 is occupying position 0, 45 is occupying position 1, 454 is occupying position 2. So when I do this and I run this, as you can see, it gave me that. So, and that's what indexing means. Indexing means like you're interested in just a function you want to get. Also, that's what indexing means. So you can also do that using arrays. So how do you index? So let's first print out our fav norm. Let's see what we have. So we have this like this. So take for example, I want to get the second element, which is 1. All I just have to do is index that. That's, it's sitting on the position 1. So 0 is sitting on position 0, 1 is sitting on position 1. So when I do one like this, so I have 1 as my output. So and also you can also do backward indexing. Backward indexing is, you're not using a positive number, but you are using a you are using a negative number. So that can be, that is what we call backward indexing. So um let's try and play around that. Okay, so now take for example, I want to get 18. Now I can start, and I start counting from the back. 19 is minus 1, 18 is minus 2, 17 is minus 3, 16 is minus 4. So it goes on like that. So if I want to get 17 now, I can just do fav underscore num, then maybe minus 2, minus 2. So as you can see, okay, I have 18 now. So minus 1 minus 2. And you will ask me, what's the significance of minus when I know I can do just 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So up to, let's say, the 18th now. Let me also print for 18th so that we can see the output. So if I do fav underscore num, then position 18, as you can see, I have 18 also. But what if my data is so long? Will I have to be counting? And it may not match up like this. So it may be very, very confused. So maybe I want to count from the back. And maybe what I want to capture is closer to the rear than to the front. So I can use that backward indexing to arrest that. So that's one way you can index. So I mentioned two ways you can index. Then also, what if you are only interested in just a portion, not just an element now, but a portion, a range? Take for example, we are interested in 2, 3, 4. Now 2 is sitting on index 2, and 4 is sitting on index 4. So now if I want to capture that data, I can do that. I will just say fav num. So fav num is starting from 0, 1, 2, that's 2. Then it's stopping where? So I put full column. Then where do I want it to stop? So it stop on 4. That is 0, 1, 2, 3, 4. But the way it is with indexing is that it leaves out the um, it leaves out the last value. So it does n minus 1. So if I run this now, so as you can see, it didn't include 4. So I will have raised it up to 5. So by doing this now, as you can see, it's captured 3 elements. So started with this is the start, that 2 is the start, then 5 is like n minus 1, like where I'm going to, like where n plus 1 rather, where I'm going to, then plus 1. So I'm going to index 4, but I need to add 1 because my indexing start from where I'm starting from, but it does not end where I in the ending value. So let's see some other ways. So I want to let's create a so from our let's create a new let me give it this name, fav reshaped, just like I have over there. So fav reshaped. So I have 10 elements. So I can reshape it. Let me reshape it to, so I will just say reshape. So since there are 10, I can reshape it to 4, comma, okay, there are 20. Let me replace it to 4, comma 50, or comma 5 rather. Then if I now call fav reshape, so now I run this. So as you can see, I've reshaped it now. Now, what if maybe you are interested in let's say 12, and your data is already looking like this? How do you go about it? Your data is already looking like this, and you are interested in 12. So how do you get here? So this is the way you get here. Now if I want to get here now, that's I've given it a new name called fav reshaped. So fav reshaped. So 5 reshaped. Then where now, as you can see, this is row 1, row 2, row 3, row 4, column 1, column 2, column 3, column 4, column 5. So now where is 12 sitting in terms of rows? 12 is sitting on the third row. So I will put 3, then I can put my comma. Then where is 12 sitting on the column? 12 is sitting on the 0, 1, 2. No, the first one is the 12 is sitting on row 3, but the way it is being numbered is this row 0, row 1, row 2, row 3. So it's sitting on 2 here now. So now for the column now, 0, 1, 2. So it's sitting on 2 also. So when I run this now, as you can see, I have 12 as my output. So when I have my numpy not to be a one-dimensional array, I can use this format to get a particular data. And you may not want to do it, you may see some other method. They will close this bracket first, and they will now put another bracket. And when you run this, still get the same thing. So you can either put a comma or you put a square bracket too. But what really matters, the first element is your row, and the second indexing element is your column. So let's look further on other ways we can work on we can index this data. So like the other time I talked about um when you are indexing from behind. So say for example now I want to get 18. Now let's assume my row is so long, very long, or let me complicate it. My row is so long and I want to get 18 and I can't afford to be counting. So there's another way we can go about that. So I can just do 5 reshape. Then I'm starting. So on the row sense is on row 3. Then where is the column? So I can say it's on column. Instead of saying column, it should be column 3 now. Okay, I want to capture it here. It should be on column 3. I can just say column -2. When I run this, so this is like column -2 means okay, I'm coming from behind. So when I use minus in indexing, it means I'm coming from the rear. It means I'm coming from the rear. So there are other ways. So in this case now, let's assume you want to capture 6, 7, 11, 12. 6, 7, 11, 12. So you can do that. All you just have to do is okay, 6, 7, 11, 12. 6 is starting from where? So that's 0, 1. So I'm starting from 1. Then the rows, it captures 11. The rows captures 11. So I will so that was 0, 1, that's 1, then 2 inclusive. So now I'm going from 1. So I know that I want to include 2, I have to include the 1 after 2. So I want to capture 6, 7, 6, 7, 11, 12. So 6 is sitting on position 1, then 11 is sitting on position 2. So but for me to be able to capture position 2, when indexing I need to put the position 3. So 1, I'm going from 1 to 3 in terms of rows. Then in column, 6 is sitting on position 1, and where I want to stop, which is 7, is sitting on position 2, but I can't stop in 2, I'll stop in 3. So when I run this now, so as you can see, I have 6, 7, 11, 12. That's a portion of that. So those are that with indexing and slicing. Indexing and slicing. So let's move on to index array. Index array. This is just another way of going about this. You can actually refer to a particular element inside your inside your array. You can refer to a particular element. That's what this index array is being used for. So let me just create another data here. Let me call it favnum equals. So let me use linspace at this time. So dot linspace. So starting from 2, I'm going to 20, and I'm skipping by 2. So let me print my favnum. So I print my favnum num. So okay. Okay, I don't want two elements. Give me just
Hello, sir. The
yeah.
network was bad earlier.
Um, Mr. Stevie, I can't hear you.
I said the network was bad. I just came.
Okay. At what point did you got cut off?
When you were explaining indexing,
Okay.
I,
Um,
I understand it, sir.
okay, you understood it, right?
Yes, I understood. I understood.
Okay. Can you look at what is on the screen? You understood everything.
Yes, down to the one where you are starting from the back.
Okay, okay. So let's move on. Then that's
Yes, my
okay. So I was talking about index array. So I just want to create 15 data points from here. So when I run this, so I have 15 data points. 1, 2, 3, 4, 5. So 5 times 3, 15 data points between 2 and 20. Wonderful. So take for example now, I'm only
yeah,
interested in, let's say, 3.2857 and let's say 18.7128. So and I'm not interested in them, so I can actually use index array to just pinpoint only them. So I can just say my fav equals fav num. So I will say mp dot array. So I will state the position they are occupying. So 3.2859 is occupying position 1, then comma, then 18.714 is occupying position 14. So let me then now print my fab. Okay, that's not callable. Something is wrong. Okay. I made a mistake here. So this should be the symbol for index. So as you can see, okay, I think there's another. So 14 should not be 14, should be 13. So I can actually use this method to also pinpoint a particular element. So I'm just removing from there. So you can use MP. So in this case now, if you look at this case now, let me reshape my namespace. Let me reshape it to, okay, since it's 15, let me reshape it to a 3 by 5, no, 5 by 3 array. So I can just do dot reshape 3, okay, 5 by 3. I run this, so I have it to be 5 by 3. So take for example, I want to get 11 from here now. I can also use index array. All I just have to do is say, let me call this 11 equals 5 num, then mp dot array. So now, okay, I want to make the same mistake again. That won't be possible. Okay. Okay, so using NPRA now, I'm going to use it to fish this out now. I know 11 is occupying the position on the row now, is occupying position that's 0 is in the row now is occupying position 2. So that will be 2, then comma, maybe np dot array, then on the row, on the column is occupying position 1. So when I now call my 11 out, see, I have the same thing. So I have 11 to be the same. So you can use numpy array, you can use the normal way. Then the last thing I'll talk about is Boolean or mask index. Now, maybe for example, as I have plenty data here, let me just insert the cell below. So as I have plenty data here, let me call it again. That's five num. So as I have plenty data here, I may want to know the one that are greater than, let's say greater than 8. So if I say 5 num greater 8, you see what I have? So where you have it to be true, there are situations where the condition I've made is true. But in other cases where you have to be false, that means those ones they are not, they did not object to that. So now there's a way you can do it such that you will just only have the data that meets that standard. And the way to do it is about, let me just say my new data equals, so I've put the condition. So what I will do again is I will call the name of the, and just put that, so with that condition. So when I run it again, okay, let me now print out my new data. Okay, that's the best thing. Okay, where's it? Where's it? Okay, where's it? Okay, I need to. Okay, yeah, you can. Okay, you can see it only returns those that are greater than 8. Those are meet that condition. So we call this boolean or mask index array. So you can use it to mask and subject it to a condition. So I don't know if there's any question. Then also you can also add value. So maybe I want to change, in this case now I have 6 7. Okay, let me look at this case now. I have my new data, and now I want to remove, I want to change the value of 11. I can actually do that. All I just have to do is to just call the 11, so and just change this. And I will do that here now. I just, let me delete this. So um I will just have my new data. um, okay, yeah. So I want to replace 11 now. So I know 11 is sitting on the position 0 1 2. That's 2. So I want to change what's in 2 to 500. So when I run that, if I call my new data again, as you can see, it has replaced the third element with 500. So I will stop it for here on Numpy. So questions are welcome, Mr. Steven. Mr. Steven, your question.
I don't have any questions, sir.
Oh, like you understood everything.